In recent anthropogenic times, an alarming phenomenon poses a significant threat to environmental and human health. This phenomenon is called a garbage patch, and one of them is located in the northern Pacific Gyre. A garbage patch is a concentration of marine debris that is made of non-biodegradable material, which is mainly in the form of plastic. The Coriolis effect creates prevailing ocean currents that take the shape of gyres. Ocean debris is widely dispersed throughout the water column and over a surface area larger than the size of Texas. The patch is not a solid mass of plastic. There are about 1.8 trillion pieces, and the trash heap weighs 88,000 tons or 500 jumbo jets. The Coriolis effect is one of the major causes of the gyre. It is a bending of Earth's winds and ocean currents due to Earth's rotation. The Coriolis effect shifts surface currents by angle about 45 degrees. In the northern hemisphere, ocean currents are deflected to the right in a clockwise motion. In the southern hemisphere, ocean currents are pushed to the left in a counterclockwise motion. The Coriolis effect also changes with latitude. There is no Coriolis effect at the equator, but the poles have the maximum Coriolis effect. It does not only influence the surface currents, but also influence the deep ocean, which is called the Ekman spiral. The ocean is divided vertically into layers. The magnitude of the velocity decreases through the layers from a maximum at the surface until it dissipates. The direction also shifts slightly across each layer. In the northern hemisphere, the direction will shift slightly to the right, while in the southern hemisphere, the direction will shift to the left. While surface currents are deflected by about 45 degrees, if all flow over the Ekman layer is integrated, the net water transportation is about 90 degrees to the right of the surface wind in the northern hemisphere and 90 degrees to the left in the southern hemisphere. The clockwise motion of the gyre in the northern hemisphere due to the Coriolis effect in conjunction with the mass transportation of the water to the right of the winds due to Ekman spiral causes a mass convergence toward the center of the gyre. This mass convergence pushes the water down deeper into the ocean.
Now that we understand the phenomenon that forms the gyres, we can look at the types of gyres dispersed through the Earth. Subpolar gyres form in the polar regions of the planet and are right below areas of low pressure. Wind drives the currents away from the coastal areas by the subpolar gyres, and upwelling causes cold, nutrient-rich water to be brought up to the coasts. Next are the tropical gyres that are formed near the equator. The winds are not affected by the Coriolis effect at the equator, so the tropical gyres don't form a circular pattern, but flow in an east-to-west pattern. Finally, the most important gyres are the subtropical gyres, which are where the garbage patches form. These are between the polar and equatorial regions and sit below regions of high pressure. These gyres happen around large, calm ocean areas that are thousands of kilometers wide. There are 5 subtropical gyres that form garbage patches. The one we are looking at is located in the northern part of the Pacific Ocean. We can see that it spans from the west coast of North America to Japan and is split into the western garbage patch and eastern garbage patch. These two garbage patches are linked together by the North Pacific Subtropical Convergence Zone, which is where warm water from the South Pacific meets with the cooler water brought down from the Arctic. The North Pacific Subtropical Convergence Zone is able to move the debris from one patch to the other. Debris off the coast of Japan flows into the Kuroshiro Current, and debris off the coast of California flows into the North Equatorial Current, and then the debris is drawn in by the gyre until it gets trapped in the stable center. As the water is pushed down deeper into the ocean due to its convergence, the larger pieces of debris remain floating at the top. Within the gyre, eddies and meanders, which are the cultivators of the current, form the eastern and western garbage patches. Researchers have found that once the garbage is trapped in the center, most of it sinks to the bottom of the ocean. But, as we just said, the larger pieces remain floating at the top. So what is this larger mass of debris sinking to the bottom? The debris is mostly composed of plastic. Most of it is slowly broken down into microscopic pieces called microplastic and tends to make the water look cloudy. The microplastics are small enough to be pushed down with water. So, although looking at the garbage patches, you are able to see the bigger pieces, the extent of its magnitude cannot be seen by the naked eye. There are many harmful consequences of the garbage patch. One obvious consequence is the water pollution that occurs when plastic is dumped into the ocean. There is an intrinsic value to the environment that garbage patch violates. Marine animals can get trapped, and ecosystems are littered with non-biodegradable material. But more concerning is the effect microplastics have on human health. Fish ingest microplastics, which are biomagnified up the food chain in some cases. Humans eat those fish like tuna and mahi-mahi, and harmful carcinogens are transferred to their system. Microplastics contaminate the ocean and can be so small that they bypass biological barriers. This means microplastics can cross cell membranes due to their extreme small size and cause tissue damage. The Ocean Cleanup Project has developed cleanup technology. Their proposal includes a trash compactor towed by a ship. Long V-shaped tubes will gather surface plastic into the compactor. The compactor gets power from solar panels. This proposal is not a definitive solution to the garbage patch phenomenon. However, this technology can help clean up the massive amount of larger pieces of surface plastic to prevent the furtherance of this alarming problem that is microplastics.